Let me get some volunteers up here. Can I get somebody? Okay, you. Come on up. Try to make this a little bit more interesting, keep you guys up. Okay, so draw me an airplane, top-down view.
Top-down view?
Yeah, top-down view. Just draw me any airplane. Anything you want. You can make it a jumbo liner or regular airplane or whatever.
Make it a guppy.
Yeah, there you go. Make it a guppy.
Make it one of those false moving flyers.
There you go. Actually, you know what? Stop right there. Stop right there. That's good. Let me go and get it. Okay, I need another volunteer. Okay, you. Come on up. All right, I need you to complete.
Don't remember my name.
Huh?
I can't believe you don't remember my name. I spent summer camp with you.
Oh man, come on, dude. Don't be like that. Here, draw the bottom part of the plane. What we're doing is we're going to pretend we're a bunch of engineers, okay? And let's say
Bottom part?
well, the back part right here. Let's just say that let's just say we're a bunch of engineers in a room and they want us to design an airplane for some top secret mission. But like most engineers, we can't decide what we want to do, so we're all going to put up our own interpretation. So let's just say he has a general idea. Let's say he wants a plane to fly low and slow, so he puts a big wingspan on it. But you're like, no, I don't want a low and slow airplane. I want a fast one that can go up and hit them high and hit them fast before they even realize what's going on. So you're going to put your own little design in it, even though it's the same airplane. So let's go ahead and draw me a fast wing, or a fast empennage on the or the back part of the plane, basically.
Usually fasts are more aerodynamic, so yes, it may look like a fish.
It's a mermaid.
All right, there you go.
Thank you.
All right, good deal. All right, I need another volunteer. Yeah, come on in. Oh, okay. Oh, you're not okay. Gone. No, I'm just joking. He's just waving on. I need another volunteer. Who? Somebody. Okay, you. Come on out, dude. All right, now let's say you don't agree with how this is supposed to. You don't agree with the plane design in general. You're like, well, it needs more wings because the more wings, the more lift it gets, right? So let's just start drawing some more stuff on there. Draw like mini wings or something. The plane needs more lift. How are you gonna put more lift on it?
Jets.
Explosive canisters.
Okay, there you go. Maybe put another one on the nose.
Make them a bit rounder.
There you go. Okay, there you go. All right. There you go. That'll work. That's what I'm talking about. Okay. So, anything else you might be missing on this plane? Anybody want to put their last little input on this before?
A window.
Huh?
Engine?
Maybe.
Engine.
Let's start with the. You need some engines. We need some engines on it. Okay. Hey, here, somebody come up and draw some engines on this thing. Okay, come draw some engines. Put some engines on it.
Rubber bands.
Rubber band.
There you go. And we'll make it a different color since it's a
It took
different.
like 3,000 tons. And we'll use some rubber bands to fly it.
The first and probably only. That's a flower. Is coming.
It's a flower!
Propeller. Okay, that's good, man. That's good. All right, go ahead. Here, watch your step there. Let me go ahead and.
It's a single turboprop.
Okay, all right.
We're being
I
environmental.
don't think that this is going to fly. It's a helicopter.
Well, you never
Oh,
know.
man.
Well, this is what's known as the initial stage in development. And then what happens is we go and argue about it, and they're like, no, well, I think this design is better. Generally what happens is you take the worst combination of a good idea, and then that's usually what the final production version is. So it happens a lot more often than you think. But okay, so cool. So we got this. So we got a little airplane right here. Okay, so let's start talking about the wings. So when you start talking about the design of wings, you want to think, well, what's the function of this airplane? Okay, now like I said, different people had different ideas what the function of this airplane was supposed to be. So what do you notice that's different about these planes? The wings have different shapes because everybody's got their own different interpretation of what the plane's supposed to do. This plane has a certain shape because its design characteristic is, okay, well, I want to go low and slow maybe and carry a lot of weight, so I'm going to put some big fat wings on it. All right? He wanted the plane to go really fast. Okay, so he's like, well, I'm going to put some, spear-like looking wings on here. This is known as a delta wing on there. Okay, so I'm going to make it fast. All right, and then he came up and he put a elliptical wing on here. Okay, because maybe he wanted more maneuverability, maybe he wanted more of a maneuverability characteristic in it than anything else. And then this right here is, then you have another elliptical design up here.
Isn't that what's on like the SU-470?
Now these actually, believe it or not, this right here actually has a valid function. They're usually not that big, but when you put them on the forward calo of an aircraft like that, they're usually known as canards. And
Canard.
well, canard, see, look at the G. Yeah, no, canard. Yeah, basically here I don't think not so much, but that wouldn't be too unlike what a lot of people try to do the first time to design an airplane. So yeah, so you got different wings, plan forms, if you will, for different designs. So what we'll do is we'll start going over the definition a little bit. Okay, this is what you want to take notes on. So what I want y'all to do is I want y'all to draw a wing on your notes right here. Okay, so draw a wing.
It's like a rectangle.
Right, well, okay, rectangle is our basic wing
Square.
design right there. But yeah, this is basically a rectangle square, okay?
Okay, drawing wing.
Alright. Now, when you're looking at the top down, this area right here is known as your wing root. Alright, so write that down, wing root, okay? Now, your wing root is where your wing is going to meet with your fuselage. And then here, on your other edge, you have what's known as a wing tip. Right here. And your wing tip is, well, the other edge, right there. Then what you have is you have your leading edge. And then you have your trailing edge. Alright. Okay, any questions so far? So you got four sides, basically four terms right there. Okay, now we're going to start talking about some imaginary lines that they use for measurement. The imaginary line from your leading edge to your trailing edge is known as your chord, wing chord, right?
Wing chord.
Wing chord. Now, going from your wing tip to your wing root is going to be known as your wing span.
That's what the S.
Right. So wing span. All right. Now, the terminology you get from this is known as your aspect ratio. Okay. Now, who knows what aspect ratio is? Okay, anybody? Okay, believe it or not, y'all deal with it every day. The word 16 by 9 mean anything to y'all?
Yeah.
Okay, so what do you think? So knowing that, what do you think aspect
16
ratio?
feet by 9 inches.
Right, exactly. But more specifically, it's width.
Space of it.
Right, exactly. It's a comparison of its width by its height. So however many units of width that you have is going to be versus how many units of, in this case, height. So you have your aspect ratio. Your aspect ratio is going to be, numerically, it's going to be your determining factor of what the lift characteristics of that wing are. And the formula for your aspect ratio is aspect ratio equals, let me see, span squared over area.
And area is just.
Right, well, the area of the wing.
Okay, so it would just be base height.
Right, exactly. There you go, yeah. So,
Tip versus trailing edge.
mhm.
Leading edge.
So, all right. Now, so that's the top part of the wing. Any questions about that? Okay, so make sure you got those terms.
Say S is the span.
Right, S is the span squared divided by area. All right, good deal. Okay, so let's go ahead and, well, I don't want to erase the airplane, so let's go ahead and start talking about the second part. So now, what we're going to do is we're going to draw a wing as if you were looking at it from the side. Okay, so we're going to draw a cross-section of it, as it were. So what we'll do is, let's say this is the front of the airplane, that's the rear of the airplane. The cross-section would be right here. All right. So then from the cross section, first of all, this surface itself, the wing has a term to it, and it's known as an airfoil. Okay, so go ahead and write that down, an airfoil. And an airfoil is any device that's designed to generate lift by either a fluid moving over it or it moving through a fluid. Fluid can be water, it can be air, it can be whatever. You know, whatever is designed to generate that lift from. So that's what an airfoil is.
So any design meant to create a lift?
Right, well, any device
Any
designed to generate lift, either by a fluid moving over it or the device itself moving through the fluid. Okay, and that's important because a wing is an airfoil, but not all airfoils can be wings. Okay, so does that make any sense?
Yes.
All right, like, okay, who's a car enthusiast here? You know, you've seen pictures of like the Subaru WRXs and all the race cars and the Formula Ones. Well, those have airfoils on them. Okay, but some of them are designed to generate lift and
On the ground.
yeah, to stay on the ground. You know, and not all of them are wings. You got splitters and you got canards and you got little vents and whatnot that are designed to basically generate lift. And lift just isn't in the upward direction. In a conventional sense, when you think about aerodynamics, you think lift is, you know, up in the air, opposes weight. But lift can also be generated in other directions. A propeller generates lift, but it's generally ready to get, you know, in a reverse direction so then you can go forward. You know, most cars will generate lift in a downward direction to generate downforce. So that's just something you want to think about. So an airfoil will generate lift, either by fluid moving over it or it moving through a fluid. Okay, now here's your cross section right here of your airfoil, which in this case happens to be a wing. Now if you were to draw an imaginary line from your leading edge to your trailing edge, okay, it's supposed to be a straight line right there. Alright, from your leading edge to your trailing edge, this is known as your wing chord. Or your chord line. Okay, so you got your chord line right here. So wing chord, and really the terminology when you talk about this is your chord line. Okay, so now this is important, and I'll go into why this is important in a second. So your chord line is basically you take it from your leading edge to your trailing edge. Now that's your chord line. Now what you have is the curvature on the top of the surface and on the bottom of the airfoil is known as camber. Okay, so basically this curvature right here is known as camber. Okay, so camber and camber right there. So you got your chord line, you got your camber, and then what you have, the last term you have, which is a theoretical line, is known as your mean camber line. So your mean camber line, I'll just go ahead and draw this. So mean camber line. Alright, so mean camber line. Alright, so which is basically the average of your upper camber and your lower camber. Okay. So anybody got any questions about that?
Yeah, how are we looking at the plane? Like,
What
is that
we're
like
looking at is we're looking at it like a
right
cross section.
side?
Right, kind of like if you're standing here. So basically, if like in this plane right here, if there was a little person standing right here, this is his field of vision right there.
Right.
All right, so that's his field of vision. So you're looking at the side of it, which I think would translate pretty well. Yeah. So this is the front of it, and this is the rear of it.
Okay.
All right. So that's just something. So that's the terminology, and you want to be sure you memorize that terminology because everything kind of branches out from there.
What's this view called?
Cross section. Yeah, cross section. Whenever you take something and you cut it in half, you see a cross section. A cross section is very popular in a lot of your technical drawings that you'll do. So cross section. So cross section. So there you go. Okay. Any questions about that? All right. Now, one last thing on it, and I'll go into this real quick. You just want to know about this, is the airplane. Okay, if we're looking at it from the front, okay, the angle of the wings in relation to the ground, to the horizontal, okay. So what I mean by that is, like, let's say this is your horizon right here. The relation of your wings in relation to the horizontal, the angle, this angle right here, is known as your dihedral. So just make sure you got that, your dihedral.
So the angle between your wings and the horizon.
Right, basically, yes. Okay, so if you draw little angle symbols right there, that's the angle between your horizontal and the angle that your wings are at.
What is it called again?
Dihedral.
Can you guess it how that's spelled?
It's spelled D-I-H-E-D-R-D-R-A-L.
Yeah, just how it's spelled. Spelled D-I-H-E-D.
Okay, cool. So any questions about that? Nope. All right. Let me get another volunteer. Well, let me erase this first, and then we'll get another volunteer. All right. Everybody memorize this design, what it looks like? Yes, no, maybe? Okay, we'll be testing on it. So there it goes. I'm sending it off to the payment board.
By economically friendly climate.
It is, yes. It's even got a flower on it. All right. Okay. Let me get a volunteer real quick. Okay, come on up. All right, what I want you to do is I want you to draw a side view of an airplane, kind of like you're looking at it from the side. So just go ahead and draw an airplane.
Anyone?
Yeah, just anyone. You can make a fighter jet, a UFO, rocket, bird, whatever. Well, a plane.
UFO. Illustrate your
Yeah,
purpose.
you can go ahead and draw a UFO if you want, yeah. Yeah, you're doing good. Okay, there you go. Are you gonna draw the tail on it real quick? Okay,
No, it doesn't.
there you go. Make it a lawn dart.
It's like a egg.
It does look like an egg.
Huh, that's actually a pretty good airplane.
Yeah.
Yeah. How many you got it? You got it?
Looks like a MiG-28.
F-86. MiGs are communists.
It's a communist UFO.
Alright, good deal, man. Alright,
Well, we captured
thank you.
it.
Alright, let me,
That makes
okay.
I'll make some fun.
Now we're going to be talking about the four forces of flight on this airplane. Okay, does anybody know offhand what the four forces of flight are? You want to take it?
A lift, drag, gravity, and thrust.
Okay, good. Well, said one thing. It's not gravity; it's weight.
Wait.
But it's associated with gravity. Because what's weight?
Gravity
Yeah.
accelerates on an object.
Right. Well, the gravitational pull of an object is your weight. And who knows the difference between mass and weight?
Mass doesn't change
Mass doesn't change. Why doesn't mass change?
because you can't change the mass of an object.
Well, what is mass?
It's the very core being of an object.
It's like the density of an object.
Well, it's how much material is in an object. It's basically the density of an object. Now, what's the difference? Okay, and people get weight, mass, and yeah. Well, you're close. People get mass and weight confused because sometimes I'll give weight and mass or mass and weight, but mass doesn't change. Weight does, because weight is the basically the pull of gravity the pull of gravity on an object. And that's going to change. The higher you go up, you know, you get into low gravity, right? You start getting into orbital, suborbital, that type of, you start getting into orbit. Well, does an object's weight change? It goes from weightless, right? From weighing so much. And then how about if you're on the moon? Something's going to weigh different when it's on the moon than it is on the Earth. And why is that? Because the moon's not pulling as much as the Earth is. So your weight's going to change, but the mass is going to remain solid. This is actually a big consideration. This is what one of my professors told me, which I didn't even realize. But, you know, force is dependent on mass times acceleration. It's not dependent on weight. So what they told me is like when they're on the space station and they're passing objects to each other, they have to be really careful how they're passing them, because even though they're weightless and they can move them around relatively easier, the force associated with it is still as if it was on Earth, or still, you know, how we know it because of the fact that it's mass dependent. So you just can't take something light and go flinging it down the hallway and thinking it's just going to, you know, boop. I mean, it's going to hit something that's going to cause some damage. So you got to be real careful about that.
I think that's pretty cool.
Yeah, exactly, yeah. I mean, it's... So, okay, so... Alright, so we're going to draw a lift, okay? And lift is actually the first thing. We're probably not going to get off the subject of lift, at least today. Let me see, because you guys are out of here in 10 minutes, so... Alright, so good deal. So, okay, so lift is, again, generated by its airfoil. So lift is your up vector, right there. So lift is going to be generated by your airfoils, okay? And again, lift is a mechanical force generated by a solid object moving through a fluid, okay? And that mechanical object, or that solid object, is an airfoil, because an airfoil is anything that's designed to generate lift by either moving through a fluid or moving over fluid, okay? Let me see. And the going into lift, you go into Newton's laws of motion, which we'll talk about later on. So essentially, going Bernoulli's equation, lift equation, the CL chart, turbulent airflow, laminar airflow. Okay, so you have lift. Now the force that opposes lift is going to be weight. Okay, so it's going to be the opposite. So you're going to have a downward vector arrow that's going to oppose lift, and this is known as weight. Okay, the force that's holding back an aircraft is known as drag. And then the force that is basically opposing drag is thrust. Okay.
So what's the one that's weighing it down? Weight.
It's weight, yeah. Let me go ahead and draw that. Lift. Lift, weight, thrust, drag.
So I take it your lift off has to be greater than your weight, or stronger or something.
Right.
Yep.
Yeah, and thrust.
And when you start talking,
Drag, yeah.
when you start talking in terms of lift, weight, thrust, drag, and your four forces of flight, when your forces are equal, basically lift is equal to weight, thrust is equal to drag, your plane is going to be what's known as equilibrium. Now, equilibrium is essentially basically a steady state. Go ahead.
Don't they have new, engines in the middle of the plane? Like the new jets where they have engines in the middle of the plane and it basically causes it to go upwards.
Oh, you're talking about VTOL, vertical takeoff and landing capabilities, where the engine will, like for example, instead of like
F-35.
Yeah.
right, exactly.
Okay, so was that in that video that you showed us during camp?
Right, exactly. And
Under its own power, it only lands vertically.
and I really don't want y'all guys to get too hung up on the concept of VTOL yet, because even though it's relatively a new, well, it's not relatively new technology. They've been working on it since the 80s now, but it's getting more refined. It's a bear to deal with VTOL because there's just a lot of changing parameters that the computer has to be able to keep up with. The Harrier was a VTOL aircraft. To a certain degree, it goes off the concept of thrust vectoring, which, has anybody ever heard of thrust vectoring?
It's in the F-22 Raptor.
Right, okay, yeah, that's where the term basically came off of, but basically where they can vector the thrust essentially to get it to where it needs to go.
My neighbor was like one of the first test pilots for the Harriers,
Hmm.
and they used to like crash them daily.
Yeah, well, hey, it's a new technology. I mean, go ahead.
Wasn't that
Just
Harrier
off the head.
just a S2L aircraft? Like it could only land vertically, but it could barely take off under its own power.
I have no idea. Now I do remember one of the biggest problems that they had with those aircraft, with the VTOL aircraft, is the fact that they're trying to get the computer technology to catch up with the mechanics of VTOL. And I think some of the earlier vertical takeoff and landing aircraft were very volatile because they start sliding to the right, start sliding to the left. I mean, that's a lot of stuff you have to manage. And some of the earlier aircraft, now you got to think, some of the earlier VTOL aircraft were probably designed in the 70s, maybe even the 80s, so they're using a lot of antiquated equipment. They're using very older equipment, even though the aircraft itself is relatively modern. So trying to get, it'd be like getting a computer built in the 2000s, or basically 2005 or 2000, modern day computer to work with 70s era technology or 80s era technology. I mean, you're dealing with a 20-year gap there in technology. You know how fast technology changes nowadays. So think about how hard it'd be to get a laptop to sync up and work with mechanics that were designed 20 years earlier, or 30 to 25 years earlier. So I think right now they're getting to a point where the mechanics of VTOL and computerization are able to basically, they're basically the same generation, and we're starting to see the fruition of it. But really, I mean, for the purpose of this class, that's really all we need to know about it. There's really not a reason to go into it. That, and I've never flown a VTOL aircraft, so I'm not really all that.
I just think it's a cool topic because, we're talking about lift and weight, and that would really help with the lift. And
Well, it does, and it does work that way, because the way, I mean, it does, and it's phenomenal, really, because for an aircraft to take off, the thrust vector and the lift vector have to be greater than its weight vector and its drag vector, okay? If the weight is greater than its lift, then the plane is going to be descending. If the drag is greater than the thrust, then your aircraft is going to be slowing down. If your thrust is greater than your drag, then your aircraft is going to be accelerating. And if your lift is higher than your weight, then your aircraft is going to be ascending through the air.
But it's okay at 35.
Huh?
But it's
Now, if they're equal, they're in equilibrium.
Okay.
And generally, for the concept of the FAA, when an airplane is in equilibrium, it's when it's in steady, unaccelerated level flight. Okay, so steady meaning that it's not climbing, it's not descending, it's not turning, and it's at an equal speed. So that's known as equilibrium. That's when your forces are equal.
So that kind of be like in the the tomahawks or whatever. That'd be like 70 knots or whatever. Kind of.
You're talking about 70 knots when they,
I guess now because you're moving forward.
Well, I mean, you'll be moving forward, but if you're unaccelerated, meaning that you're not going faster than 70 knots, or you're not accelerating from 70 knots, you're not slowing down from 70 knots.
It's just like at a steady pace.
Yeah, if you're at a constant 70
Okay,
knots,
okay.
at a constant altitude, and you're not turning left or right, then you're in equilibrium.
Yeah.
Then the aircraft's in equilibrium. So there's a lot of balancing act going on, and of course, what would have to happen is a plane would have to be, when it's at a standstill, its weight and its drag are going to be its greatest vectors right there, and the thrust and the lift are going to be marginal to none because the engine's not starting, it's just sitting there on the ground. Now, when the engine starts, what happens is the engine is overpowering the mass of the aircraft, moving it forward, and that's what's accelerating it. As it's accelerating, its airfoils are moving through the air, which is generating lift, and the lift is what's overpowering its weight, and which is what's taking it into the air. And so the engine and the airfoils are doing the work. Everybody kind of hanging in there? Kind of got it. All right, so now what we're going to talk about, like tomorrow, and what we're going to talk about going into next week, is we're going to start delving into this, because there's different types of lift, there's different types of weight, there's different types of drag, and there's different types of thrust. So there's different measurements and how we do it and everything else. So tomorrow we're going to delve more into your lift concept, and we'll start talking about high lift devices and how a plane generates lift, and how a pilot can control lift, and so on and so forth.